Thanks for joining Data Platform Virtual Summit 2022. My name is Liu Li. I'm the Program Manager of Azure Data Factory team. I'm very happy to have this opportunity to present this session. Today, I'm going to talk about one topic, Managed Virtual Network in Cloud Scale Analytics. This is today's agenda. I will talk about some basic concepts of Managed Virtual Network. Then I will show some new features in the last couple of months as well as the best practice of how to use them. What is the most efficient way to leverage these features in your use cases? The last part will be a roadmap for Managed Virtual Network in near future. Hopefully, we can have a wonderful time in next hour. Let's start with some basic concept of Managed Virtual Network. So why is Managed Virtual Network? Enterprise readiness in areas of network security is top of mind for most of enterprise customers. Managed Virtual Network provides customers with a secure and manageable data integration solution. Since we announced the general availability on October 1st last year, we see more and more customers using this feature in their production. With Managed Virtual Network, customers can provision the Azure Integrated Runtime as part of a Managed Virtual Network and leverage private endpoints to securely connect to supported data stores. The traffic goes through Azure Private Links, which provides secured connectivity to the data store. Before we introduced the Managed Virtual Network, Azure Data Factory had three kinds of integrated runtime: Azure Integrated Runtime, Self-Hosted Integrated Runtime, and SSS Integrated Runtime. SSS Integrated Runtime is not in today's session scope. For the other two kinds of integrated runtime, Azure Integrated Runtime and Self-Hosted Integrated Runtime, each of them has its own advantages and disadvantages. Azure Integrated Runtime provides a fully managed serverless compute in Azure. You don't have to worry about infrastructure provision, software installation, patching, or capacity scaling. In addition, you only pay for the duration for actual utilization. But all the data transmission is through public network, which is not secure enough. Especially some customers' state stores are in their virtual network. They have to configure additional settings on their firewall to allow Azure Integrated Runtime to access the data stores inside. Another big disadvantage for Azure Integrated Runtime is that it's difficult to access on-premises data stores. So for Azure Data Factory, introduce self-hosted integrated runtime, which can solve the problems that the Azure Integrated Runtime has. If you want to perform data integration securely in a private network environment, which doesn't have a direct line of sight from the public cloud environment, you can install a self-hosted integrated runtime on-premises environment behind your corporate firewall or inside a virtual private network. The self-hosted integrated runtime only makes outbound HTTP-based connections to open internet, but the self-hosted integrated runtime is lack of some advantages of Azure integrated runtime, such as fully managed serverless. Customers always have concerns that they have to manage the self-hosted integrated runtime by themselves, and they don't know for certain workload how many self-hosted integrated runtime nodes they need, what are the specs of these machines. If the performance reaches to the bottleneck, how to optimize, how to scale up or scale out. Another big disadvantage that self-hosted integration runtime has is data flow. We all know that more and more customers prefer to use data flow to do data transformation. After data is presented in a centralized data store in the cloud, typically the next step is to process or transform the collected data by using the ADF mapping data flows. Data flows enable data engineers to build and maintain data transformation, perhaps that execute on Spark without needing to understand Spark clusters or Spark programming. One of the disadvantages of self-hosted integrated runtime is that it doesn't support the flow. So if we can have one kind of integrated runtime, which can have the advantages of both Azure integrated runtime and self-hosted integrated runtime, fully managed, serverless, and can securely access private network, but don't have these disadvantages, then some customers can leverage it in their current or future projects. That's the reason why we want to develop a feature called ADF Managed Virtual Network. This page is about how to enable Managed Virtual Network. There are two ways to enable it. One is when you create a new data factory in Azure Portal, you can enable it in networking section. The other way is to create a new Azure integrated runtime with Managed Virtual Network enabled in an existing data factory. There's no much difference between these two ways. Only in the second way, you may already have a default Azure integrated runtime, which is called auto-resolve integrated runtime. This integrated runtime cannot be deleted even if you create another managed virtual network integrated runtime. Another thing that you need to pay attention is that each managed virtual network integrated runtime has a specific region. The region is always the data factory region. It cannot be auto-resolved like public Azure integrated runtime. For data access, although you can access data stores via private endpoint when using managed virtual network, you can still access these data stores via public network. Today, we don't block any public outbound communications of managed virtual network because some customers have requirements to access some non-Azure data sources, or some Azure data sources which haven't supported private endpoint. There is a new feature called data exfiltration protection to cover this. We will talk about it in the new feature part. Then, what is managed private endpoint? Managed private endpoints are private endpoints created in the data factory managed virtual network that establish a private link to Azure resources. Data factory manages this private endpoint on your behalf. They are not functionally different from other general private endpoints, just created under a different virtual network. So for managed private endpoints, users cannot see them under their own subscriptions or resource groups. They are created under the subscription of ADF service. You don't need to manage them, but how the charges incurred by managed private endpoint, such as data transfer and the private endpoint itself, are recorded under the user's bill. Under ADF's Managed Hub, you can explicitly create a managed private endpoint by selecting the data store or Azure service you need to connect to. After the creation is completed, a connection request is actually sent to these data stores or Azure services. The application must be approved by the owner of each data store or Azure service, so that the private link is connected successfully. You can also see the status of each managed private endpoint on ADF portal, first pending, then approved if the request is approved, otherwise denied. What I want to talk about in this slide is that we see many customers cannot figure out the difference between ADF Managed Virtual Network and ADF Private Link support, and always think they are the same thing. At the top is the ADF Managed Virtual Network, which means you can provision an Azure integrated runtime in an ADF Managed Virtual Network. You can leverage private endpoints to access data stores via private link. It's a secure solution for data integration. The feature at the bottom is actually another feature related to security. It's more about the communication from end user to ADF service. The end users include both portal access, API call, and self-hosted integrated runtime access to ADF service. So in essence, both use the same technology, private endpoint and private link. But the difference is that the first one is the virtual network managed by ADF, and the other is the user's own virtual network. Another difference is that one is connected to the external data store, and the other is connected to the ADF service. So these are two completely different functions. Another thing I want to talk is the difference between managed virtual network in ADF and Synapse, which is also a frequent ask from our customers. Generally to say, they are nearly the same, use the same technology and near the same architecture and user behavior. But they still have some small differences because they are used in two different products. Azure Data Factory as a standalone data integration solution can support different types of integrated runtime in the same data factory. So you can have both public Azure integrated runtime and managed virtual network integrated runtime. You can use both private link access and public access in the same data factory. But in Synapse, you can only have either public integrated runtime or managed virtual network integrated runtime in one Synapse workspace. When you create a workspace, you must choose whether to enable managed virtual network. If you enable it, only managed virtual network integrated runtime can be created. You cannot create a public Azure integrated runtime. Self-hosted integrated runtime is an exception. You can always create it in Synapse Workspace, no matter is a managed virtual network enabled or not. Data exfiltration is another difference in managed virtual network between Azure Data Factory and Synapse. Synapse has already supported. You can enable it during the creation of Synapse Workspace. But in ADF side, we are still in private preview right now. It's planned to be released in near future. The last difference is the enablement of managed virtual network. In ADF, you can either enable it during the creation of the factory or the creation of integrated runtime. I have shown the two ways in previous slide, but for Synapse, you need to decide it during the creation of the workspace. With some of the more confusing concepts out of the way, let's take a look at some of the new features we will release in recent months. Below, we will focus on these features and how to use them most efficiently. The first new feature is time to leave, or we say TTL in managed virtual network. Although managed virtual network can provide a secure data integration solution and can fit a lot of business scenarios, but one limitation we have today is that the queue time for activity execution is longer when using managed virtual network. It's technically because when a customer enables managed virtual network in a data factory, we will create a dedicated virtual network to this data factory, which means we cannot leverage existing reserved compute pool. Each time we need to provision a compute in this managed virtual network for activity execution. The provision takes around 1 or 2 minutes. In the worst case, if you have, for example, 100 small copy activities, the execution of each could be just several seconds. But before each copy activity execution, the queue time or compute provision time will take 1 or 2 minutes. It's not time and cost efficient. So in order to mitigate this limitation, we introduce TTL. TTL, as the name implies, is that the compute used to run various activities will be retained for a period of time after the operation ends, and the compute will not be released during this time. If there's a new activity, compute does not need to be reprovisioned, so that the queue time of subsequent activity execution can be avoided. TTL is a very common concept, especially for some machines or clusters that take a long time to start. For example, the data flow of the data factory uses the same concept to solve this problem. For managed virtual network, you can configure the TTL settings either in Create or Edit Azure Integration Runtime page. So it's in integration runtime level, which means if you have more than one Azure integration runtime with managed virtual network enabled, each one can have a different TTL settings. But make sure to select the right one when you create link service. Otherwise, it won't take effect as you expect. Actually, we have different kinds of compute in integration runtime for different activities. So for different compute, we have different TTLs. The typical ones include the first one, interactive authoring, which is used for like test connection, preview data. The second is for copy activity. The third is for external and pipeline activity. In the screenshot, you can see they are in different sections. You can enable, disable, or configure the TTL period respectively in the setting page. But are there any difference among these three kinds of TTL? The answer is yes. There are small differences among them. For interactive authoring, we know that it's used in development phase. Data engineers use it to test connection, preview sample data, and etc. when creating or editing linked service. It can highly help data engineers to validate their configuration and pre-test their connection to some degree. We rarely use it in production environments because the pipeline must be stable, and we rarely change the connection settings in production environment. So you can enable it when you develop pipeline or create linked service. And the TTL period might be longer than copy or external activities because you may need to focus on modifying and testing your linked service and pipelines for a certain period of time. You don't want to re-enable every once in a while. This is very inefficient. The biggest difference between it and other TTL is that once enabled, it will take effect immediately, whether you use it or not. Of course, you can disable it when you finish your work or do not want to use interactive authoring. The reserve compute cannot be configured, and the default TTL value is 60 minutes. You can configure it shorter or longer as you wish. We have multiple options in the drop-down list. The next TTL is for copy activity. Not like interactive authoring, copy activity does not take effect immediately when you enable it. We only provision compute when you run the first copy activity, then reserve the compute and do not release it within TTL period. In other words, the first copy activity will still have the queue time, but subsequent copy activities that run within the TTL period will no longer need to re-provision compute, and the queue time will be almost zero. One thing that you need to pay attention is that not every scenario is suitable for copy TTL. In next slide, I will talk about when to use copy TTL and when not to use it. Also, for copy TTL, you need to choose the DIU number you want to reserve. Too big or too small may not fit your requirements. These DIUs are reserved to run all the copy activities, and the DIU or compute cannot be elastic. So here you need to remember, with TTL, the elastic mode of Azure Integral Runtime is changed to be reserve mode. So do choose the DIUs which is big enough for your copy activities. Otherwise, the performance will be impacted due to lack of compute. The last TTL is for pipeline activity and external activity. By default, it is enabled and you cannot disable it. But you can choose the TTL period. The default value is 1 hour. Like copy TTL, pipeline and external activity TTL also take effect when the first activity runs, which means that there is still queue time for the first activity. However, as long as the subsequent activity runs within the TTL period, there will be no queue time. Unlike copy TTL, the user does not need to choose the size of the reserved compute. The main reason is that pipeline and external activity do not require a lot of compute like copy, especially external activity. ADF mainly does the work of orchestration, and the real operation is in the external service. Of course, it may be a little different for some pipeline activities. For example, lookup activities may require a lot of compute. We may make adjustments in this part in the future. Apart from that, there are two things you need to be aware of for all TTLs. The first is that when you disable TTL, all running activities will run with the previous TTL settings until the end of the run. That is to say, disable TTL cannot stop the running of the current activities, nor can it immediately switch the running activity to elastic mode. This modification will take effect on subsequent activities. Another point to note is that although the user cannot choose the size of pipeline and external activity TTL compute, the default compute can have a certain amount of concurrency and can run 50 pipeline activities or 800 external activities at the same time. Like I said on the previous page, not every scenario and use case is suitable for TTL. On the contrary, in some cases, Using TTL will cause performance downgrade. We introduce TTL to address some of our known issues. In this page, I list several typical scenarios and will go through them one by one. The first scenario is common in some companies with frequent transactions and may need to run some small copy jobs continuously, and the running time of each job is very short, maybe only a few minutes or even a few seconds. In the absence of TTL, each copy activity has a queue time of 1 to 2 minutes, which may even be longer than the running time. This situation is very suitable for using TTL. Set an appropriate TTL period, except that the first copy activity still has a queue time. The subsequent copy activities have no queue time and can be run directly. The second scenario is similar to the first one, except that many small copy jobs are looped through for each. Because for each can allow parallel running, for example, 50 copy activities can run in parallel. But if there are a total of 2,000 copy activities, for example, then the second batch of 50 copy activities needs to wait for 1 to 2 minutes of queue time. So in this case, you can also reduce the waiting time by setting TTL and provide overall operating efficiency. The third case is what we call interactive authoring. The data engineer needs to modify and test the pipeline and the link service within a period of time. In this case, turning on the TTL of interactive authoring will improve the overall development efficiency. The fourth case does not apply to TTL. If you run a copy activity or a pipeline external activity a few times a day, and the interval between the two is very long, then it's not suitable to use TTL. Because TTL is also charged, setting too long TTL is not cost efficiency. The last scenario is one activity runs for a long time, possibly for hours or even days. In this case, the queue time of 1 to 2 minutes does not affect the overall efficiency. Because TTL needs to reserve compute, compute cannot be dynamically adjusted, so it may affect the operating efficiency. These 5 scenarios are only part of all scenarios in ADF. The purpose of listing here is to remind everyone that TTL is not suitable for all places. You need to decide whether you need it or not according to your actual needs or specific environments. At the same time, some comparative tests need to be done to compare the performance difference with or without TTL. From this page, let me talk about how we charge customers with and without TTL, and what is the difference between these two cases. I pasted a screenshot of the factory pricing page in our public document. There's no difference in orchestration, the flow, and monitoring no matter what kinds of integrated runtime you use. So let's focus on data movement activity, pipeline activity, and external activity. Actually, for data movement activity, or say copy activity, the price is the same as public Azure integrated runtime. But you can see a significant difference in pipeline and external activity. Because the whole architecture is different and we need to be inject and release nodes in main virtual network, so the COGS for use is quite different. But we do provide a concurrent feature for these two kinds of activity. You can concurrently run 50 pipeline activities or 800 external activities, but only be charged once. So if you want to have a more economical solution, you can redesign your pipelines and activities concurrency a little bit. Below, I use a few specific examples to illustrate the difference between whether it is a TTL or not. Example 1. If there are 6 copy activities executed sequentially, 4 DIUs are used for each copy activity, and the execution time of each is 40 seconds. Assume the queue time is 1 minute and no TTL enabled. Because there's no TTL, so every copy activity has 1 minute queue time and every activity execution time rounds up independently. So we charge the execution of each activity 1 minute, plus the DIU is 4, so the total cost is like the formula at the bottom. Now we have a similar case, example 2. Still, there are 6 copy activities executed sequentially. 4 DIUs are reserved and the execution time of each is 40 seconds. Assume the queue time is 1 minute and the TTL is 5 minutes. The only difference from example 1 is TTL is enabled in example 2. From the results, only the first copy activity has a queue time of 1 minute, and because of the TTL, the compute becomes the reserve mode. That is to say, we will charge for the reserve compute. In this example, the 6 copy activities run for a total of 40 seconds multiplied by 6, which is 4 minutes, plus a 5 minutes TTL. The final result can be seen in the formula below. As can seen from this example, in the case of TTL, since the compute is reserved and the running time of the activity is no longer rounded up individually, but rounded up according to the overall running time. This reduces the overall cost to some extent. Of course, not every situation using TTL will reduce the operating cost, and it still needs to be analyzed on a case-by-case basis. It is best to do some comparative tests to find out the most economical and best solution. The last example is about external activity. Example 3. If there are 6 HD inside activities triggered by for each, the execution time of each is 9 minutes and 40 seconds. The parallel is configured as 50 in for each. As the TTL cannot be disabled for external activity, we can just change the TTL to 30 minutes. The execution time of each HD inside activity is rounded up to 10 minutes. As the 6 HD inside activities run in parallel and within the concurrency limitation 800, they are only charged once. You can see the formula below for the final cost. As can be seen from this example, a relatively economical way to use a managed virtual network to run a pipeline or external activity is to run some activities in parallel and only charge one cost as long as it is within the concurrent limit. Below, we introduce the second new feature. For managed virtual network, it is crucial to support more the stores and the services. Connecting to listed stores and services through private endpoints and private link is the biggest difference between the general public Azure integrated runtime and the managed virtual network integrated runtime, because the latter provides a more secure data integration solution. After the data stores and the services that were initially supported, in recent months, we have newly supported the following data stores and services: Azure Function, Azure Data Explorer, and Azure SQL Managed Instance. The Azure SQL Managed Instance is still in preview. In the future, as more Azure data stores and services support private link and private endpoint, we will also add corresponding support in ADF. And from Azure as a whole, this will be a trend. The next new feature is data exfiltration protection. With data exfiltration protection, you can guard against the malicious insiders accessing your Azure resources and exfiltrating sensitive data to locations outside of your organization's scope. At the time of managed virtual network creation, you can choose to configure the integrated runtime with the managed virtual network and additional protection against data exfiltration. With data exfiltration protection, integrated runtime within the managed virtual network always communicate over managed private endpoints and can only connect to authorized Azure resources. You also can manage the list of approved Azure AD tenants for the managed virtual network. If you are familiar with Synapse Analytics, you can find a similar feature which has already been supported in Synapse Workspace. We are going to introduce the same functionalities into ADF. Because one data factory can only have one managed virtual network right now, so when you first time enable managed virtual network, you can choose whether block outbound data traffic or not. You cannot change this setting after that. Let's use an example to illustrate data exfiltration protection for managed virtual network. For example, we have a company which has Azure resources in tenant A and tenant B, and there is a need for these resources to connect securely. A managed virtual network has been enabled in tenant A with tenant B added as an approved Azure AD tenant. If we need to move the data from storage in tenant A to the storage in tenant B, then we need to create a private endpoint connections to Azure storage accounts in tenant B from tenant A, and the private endpoint must be approved by the storage account owners in tenant B. All public connections between tenant A and B are blocked because we enable the data exfiltration protection. This page is about how to access the sources in private network. We all know that one disadvantage of public Azure integrated runtime is that it's not able to access the sources in private network, such as on-premises or customer virtual network. So we introduce Salesforce integrated runtime to solve this problem. Now, with managed virtual network, Azure integrated runtime can also access data sources in private network. It needs additional setup and configurations. The basic idea is to set up a private link service and load balancer in your virtual network. In ADF side, you need to create a private endpoint against the private link service. So the request will be from integrated runtime in ADF managed virtual network to private link service in customer virtual network via private endpoint. Then forward the request to the data sources by load balancer. If your on-premises network is connected to your virtual network via Express Route or VPN, then it also can access the sources in on-premises environment. This solution provides you a serverless and managed compute for your ETL scenarios without any maintenance of self-hosted integrated runtime. But it cannot fully replace self-hosted integrated runtime, as not every on-premise environment is connected to Azure via Express Route or VPN. The setup of this solution is a little complicated, to be honest, and needs some networking knowledge. Now, this solution can support such as on-premises SQL Server, Oracle, Azure SQL Main Instance, and Snowflake. In this part, let me talk about the future development direction of managed virtual network and the potential roadmap. Because we need to dynamically adjust our strategy according to the actual needs of our customers and the development trend of this industry. I cannot guarantee that these items on roadmap will be implemented. Some items not listed below may also be implemented in near future. So, if you or your customers have any news about managed virtual network, please contact me and the ADF team. We will prioritize them according to the actual situation. Because we just mentioned that many important features are still in private preview or public preview, it is imperative to develop these features to GA state, including TTL in managed virtual network and data exfiltration protection. This can be very helpful for many customers to apply these features to their production environment. In addition, we will support more stores and services. This will greatly enrich and improve the usage scenarios of managed virtual network, so that more customers who are using public Azure integrated runtime or self-hosted integrated runtime can migrate to managed virtual network. We will also try our best to make up the gap between. The last point is that we will find a way to simplify the existing settings for private network access, so that the customers can more easily set up and build a complete set of environment and solutions. Okay, that's all for today. If you have any questions or feedback on the above, please contact me or the ADF team. We will do our best to help you. Thank you all for listening to this session.